For today, we're going to look at, once again, experiments. What to do with our samples once we got them. There are two types of studies, observational studies and experiment, that I went over yesterday. An observational study is a study based on data in which no manipulation of factors have been employed. An experiment is a study where factors are manipulated. So observations is pretty much self-explanatory. We're just looking at things happening. Experiments, we're kind of adjusting things and seeing what happens accordingly. There are types of observational studies: retrospective, where subjects are selected and their previous conditions or behaviors are determined, and prospective, subjects are followed to observe their future outcomes. So retrospective is previous, so in the past, think the word retro. When you think retro fashion, you think maybe 80s or 60s or whatever. And then prospective is future outcomes. Again, I like to look at pictures. So study designs, we have observational, experimental. Observational, no treatments is imposed. There's no control group. We're just sitting there and observing and seeing what's going on. Experimental, there is a treatment imposed. There often is a control group, something to compare our data to. Let's see, what else? So with the experiments, we would want to randomize our participants. With observations, not so much. Retrospective and prospective. So think of, you see somebody with a skin rash. Retrospective is, well, how did that rash occur? So you're going back to previous data and seeing how did they get to this point. Prospective, you're looking at seeing, okay, this person has a rash, will it develop into cancer later? So prospective is you start at the beginning and you're looking at future outcomes. Retrospective, you're at some point and you're looking at the past. So you're already there. You're trying to figure out, why did this happen? Looking at previous data. Prospective, you're looking at what will happen if I do this. Okay, let's look at some examples. An article in a local newspaper reported that dogs kept as pets tend to be overweight. Veterinarians say that the diet and exercise will help these chubby dogs get into shape. The veterinarians proposed two different types of diets, Diet A and Diet B, and two different types of exercise programs, Plan A, Plan 1, and Plan 2. Diet A, owners control the portions of dog food and the dog treats. You just grab and go, give it whatever. Diet B, a mixture of fresh vegetables with the dog food and substitute regular dog treats with baby carrots. So the dog's eating healthier. Plan 1, so the exercise plans, 3 30-minute walks a week. Plan 2 is 20-minute walks daily. 6 dog owners volunteered to take part in an experiment to help their chubby dogs lose weight. So let's look at the subjects. What would be our subjects? What are we testing? Or what are we experimenting on?
Dogs.
Yeah, dogs. More specifically, 60 dogs, right? 60 fat dogs. Factors and number of levels for each. So what am I changing in this data? Okay, very good. So I'm looking at the diet. How many levels do I have with my diet?
2.
2. I have Diet A and Diet B. What else am I looking at?
Exercise.
Very good. Exercise. And how many levels of exercising?
3.
I have 2. Plan 1 and Plan 2. Number of treatments. So, how can we separate diets and exercise? I'm going to have Diet A. And the Diet A dog is going to have exercise Plan 1. I'm also going to have a Diet A with exercise Plan what? 2. What other kinds of treatments will I have? So Diet A Plan 1, Diet A Plan 2, Diet B, what? Plan 1. And Diet B, Plan 2. So how many treatments will I have? 4. So there's 4 number of treatments. See how we're classifying treatments? How we're separating this out? So we're testing, was diet A effective with plan 1? Or maybe diet A was plan 2 was better? Or maybe diet B with plan 1 was better? Or maybe the best one of all was diet B with plan 2? Now, how do we determine the best one of all? What is my response variable? What am I looking at here? Very good. My response bill. Weight loss. And I skipped one here. Is this experiment blind or is it double blind? First, is this a double blind experiment? No, because what does it say about diet A? Owners know that they have control of the diet, right? Diet B knows that they have the vegetables. They have a little healthier plan. So it is not a double blind. What about a single blind? So there's only two types. Is that the experimenters and then the observers. Would the observers know? The people weighing the dogs, will they know? Probably not. No? They don't have to know, right? So you don't have to tell them which dog was in which category or which treatment. So I would say this was a single blind, yes. Single blind where the evaluators don't know, don't have to be given this information. Why tell them? You don't want them to, this was on the really good plan, diet B and plan 2, so I'm assuming it's going to lose weight. So maybe I'll round down the weights. I don't know. Don't need to tell them. Don't bother. So design an experiment to determine whether the diet and exercise programs are effective in helping dogs lose weight. So I have a total of 60 dogs. You've already told me the treatments. So I have diet A, that's fine, with plan 1, diet A with plan 2, diet B with plan 1, and diet B with plan 2. Now, I only have 60 dogs, so how should I separate it? I'm not going to test all 60 dogs in each of these, am I? That's not going to make sense, right? You're not going to do it one at a time. So how many dogs am I going to put in each treatment? 15, right? Separate it, 60 divided by 4. So this is going to be 15 dogs here, 15 dogs here, 15 dogs here, and 15 dogs here. At the end of all this, what am I measuring? The what? Yeah, weight loss. So there's my experiment plan. I grabbed 60 dogs. Again, these were probably, what is this, volunteered, so I don't have control over that. But I do have control where I want to put the dogs, and then I'm looking at their weight loss at the end of the experiment. Any questions on designing that plan? So, yep, what we got? Next, a group of people are concerned that the coach of a local high school men's and women's basketball team alters the amount of air in the basketball to gain an unfair advantage over opponents during home games. The idea that the basketballs are pumped up with 1 pound per square inch less air than required, and his team practices with these altered balls all week prior to the home games. Since these underpumped basketballs would react differently when they hit the rim, the team that practiced with these balls will have an unfair rebounding advantage when the balls bounce off the backboard and rim. We want to see, is this true? Does he have an unfair advantage? Describe how we would use a retrospective study to determine if the home team has an unfair rebound advantage. Retrospective, so that means I'm looking at what? Past data, right? So how can I set up a experiment using past data? Notice, I'll give you a hint. Has been doing this already, has been altering balls. So how can I set this up as a retrospective study? Let's first think, what is my treatment? What am I changing? What changes here? The what? Yeah, how much air is in the ball. Will we know that previously from past games? I mean, we can ask the coach, right? So do a survey. Which games did you underinflate the balls? And maybe look before that. When did you start doing that? So when were you using regular balls? And we're looking at what? What other kind of previous data do we have? Rebound. They keep that stats, don't they? This home team rebound has this many rebounds. The away team had this many rebounds. Offensive and defensive. So yeah, we can use this study to look back and see, okay, home team had 15 rebounds, away team had 16. Did you use underinflated balls, coach, or were you just normal balls this game? Also note that this was only for what? Home games. So we can look at away games and see if there was a difference in rebounding compared to home games, right? So, a retrospective study is an observational study in which past games are reviewed to see how many rebounds a team had when they had the altered basketballs versus when they had basketballs that are pumped correctly. So you can actually look at home games versus away games. The differences in the number of percentage of rebounds made will be compared between the two types of basketballs. Describe how to use a prospective study to determine if the home team had an unfair rebound advantage. So how can we set up a future study on this? Very good. So we're going to have normal balls and let's see, we'll just say inflated. And then we're going to have games. And then what are we going to look at? Yeah, the rebounds. Very good. So a prospective study is an observation study in which teams are selected and then their future rebounds are recorded to see if they improved when they have the altered balls. So what is my subjects here? What is my subjects for this experiment? Subjects? Or maybe there is no subjects. What is my experimental unit? What am I using to get data? The basketball games, right? So we'll just put the games. Because if I'm using a retrospective, I'm using it looking at previous games data. Treatment. What changes here? Yeah. The air in basketball. How many levels do I have with this treatment? How many times do I change the air in the basketball? So what types of basketballs do I have in this experiment? Two. I have 2 levels, and they are the normal basketballs, right? And the inflated. Or underflated, sorry. They Tom Brady these basketballs, didn't they? What is my response variable? Rebounds. Rebounds, probably rebound percentages, right? Compare the home team versus the away team. And let's see, let's design this. So I think I've designed in the previous one, actually. So we have games, and then we're going to randomly choose which games we're going to have normal balls and inflated balls, and then we're going to look at the rebound percentage. Would you say this is a double-blind experiment? Could you double-blind this experiment? Would you tell the coach which balls you gave him? No, right? I wouldn't tell him. Just say, here's the balls we're experimenting on, and only you know as the experimenter if they're underflated or normal. Would you tell the person that's counting the rebounds? No. So this would be a type of double-blind experiment. So type of ball used in each game without letting the players or their coaches know. Maybe you don't even know. Maybe you randomize it. Give it to somebody else. Have them decide. And yes.